So hello guys, welcome you all to debugging doubts. So today we'll study the topic about semaphore. So in the previous section I have discussed about the Peterson solutions. So now let us move to a semaphore. So what is the semaphore? So it is basically a variable. So you can see here the s is a semaphore variable. So it is shared with all the current functions, and whenever you perform wait and signal, it should be accessible. So let us discuss with for example first. So consider there are processes like P1, P2, P3, P4. Okay. Now let semaphore let s value be let it be 2. So when you try to execute such kind of this thing processes, so when process P1 request for some resource, yes value will become 1 because it keeps on reducing. And when process P3 request, it will become 0, and when P2 request, it become -1. So this way, so you can see in the wait. So why this wait is used? So whenever you call any process in the waiting state, so the semaphore value keeps on decreasing, you can see. So when s is less than equal to 0, only then it will be busy. So what was my s value? Initially it was 2. So 2 is less than 0, no, it will be false. So it will come out of the while loop, and s minus minus, so it will decrement. So that's why when P1 requested, 2 became 1. So when P3 requested, once again it checks 1 less than equal to 0. No. So once again it reduced to 0. And now it will check is s value less than 0. When P2 request, so it will check is s is less than equal to 0. So it is true. So what it does, you can see there is a semicolon. So it will keep on looping. It will keep on checking, and it will be in the waiting process. Then whenever any other process comes, the yes value keeps on it will be staying 0 only. And when P1 after executing, it will terminate, right? So signal will say that increment the yes value. So it was 0, so it will become 1. And when P3 terminates, again a signal is called, so it will increment, and it will become 2. So this way we can fix the limit of memory resource. Like yes is 2 means there is only 2 memory locations, and in that you need to use it. And whenever another third one request, so you don't have any space, so you keep it in the waiting process. So this is what the function does. So what is the disadvantage of this? As you can see, whenever the s value is 0, so if P4 is also requesting, for both the process, the while loop keeps on running infinite number of times. So this will actually waste the memory, waste the time, right? And also the process utility. So we have another kind of wait signal this thing algorithm. So let us discuss about it. So in this process, you can see there is a type def struct. So here we have defined a variable. Instead of giving a primary variable, I am giving a user defined. So here semaphore is my this user defined data type, and value and process is present in this structure. So now let us discuss how it works. So first is wait. Here the wait takes the semaphore value and then does some kind of process, and signal also takes the semaphore value and does kind of some process. Okay, now let us see. So yes value, first thing what it does is it will decrement the yes value, and then it will check whether yes dot value means yes is a kind of structure, right? In that value is this integer number, so it will check whether it is less than 0. So here in the case, let us start from yes value is equal to 2. Okay, so one process will request, and it will be running now. So yes value will be subtracted, so it will become 1. Then it will check 1 less than 0, then it is, if 1 less than 0 is false, right? So it will not go this, and it will directly assign the process. The actually the codes are written in some other segment of the code that I will discuss later, but I'm just telling about the concept. So whenever the P3 will request now, second time, so it will decremented and it will become 0, and then 0 less than 0 is false actually. So this will add to the process. Then this it will be added to the queue. So there will be a waiting queue where we'll add the process which are been waiting, like P2, P3, whichever process ask after all that all the things are added to waiting queue. Now what happens in the signal? So in the signal you can see first it will increment the yes. So if it is 0, then it will keeps on adding, and then what it does is it will check the condition, that is if value is less than equal to 0. So if the value is yes value is negative, that means there is some process which are in the waiting queue, and it should remove a process from that waiting list and then wake up P. So this is what it states. So as you can see, whenever the process is less than 0, then only we are adding it to the waiting list. So that's why whenever the yes value is less than 0, then only you need to remove the process from the waiting list. So yes dash list is waiting list. Okay, so this is how you need to follow. Now a kind information note you can see here. So yes value is decreasing in wait function, right? So whenever wait is called, yes value is decreasing, and whenever signal is called, yes value is increasing. So that this is the main important point which you need to keep in the coming further part. Now let us understand about some classical problems of synchronization. So there are three problems. One is producer consumer, the one is reader and writer, and the final one is dining philosopher solution. So let us understand about the producer and consumer process. So here the four things we need to initialize, that is integer is n. So there are how many number of process it can have, like how many number of resources, or you can also say the semaphore value also. Then we have semaphore mutex, that is set to 1, and then semaphore empty is n and full is 0. So why this we have initialized, I'll tell in the coming part. So what does the producer process do? So whenever a producer produces any kind of processes, that is put into the buffer, and whenever the consumer is called, it will remove the item from the buffer and use it. So this is what basically it does, but we need to keep in mind that both of them while running concurrently should not interrupt or give any kind of error. So that's why we use these three variables. So let us understand. So first thing we are checking is there is kind of this thing buffer. So 1 0 1 2 up to n. Okay, this way there is some kind of buffer, and whenever the producer is called, first thing it will do is it will check the wait empty. So what does the wait do? It will every time subtract the value, as you see in the previous one. So the empty value is n here, so it will reduce it to n minus 1, and then mutex is set to 1, right? So that also wait, because of wait it will be subtract to 0, and then it will go to the next produce. So the buffer this thing will be activated, and then here you will add the one more value. I'll keep write it as v. Okay, some value it will try to add to the buffer. Then what I do after adding, I will say I have added, so I need to release the mutex. So it was 0, so I need to set it to 1. So I will add by using signal. So by using signal I will say that I have successfully added into the buffer. Then I will say signal the full, because we have added one item, right? So I need to increment the full. So full was 0, right? So that's why full will become now 1, and empty was n minus 1. So this way whenever I add some process, it keeps on empty keeps on decreasing and full keeps on increasing, and mutex is used to tell that. So if it is 0, then other process will not get into it. So as we discussed in the Peterson solution, same way you need to remember. So now let us consider one more item it will add. So it is empty is n minus 1, it will become n minus 2. Then mutex after this process was 1, So once again it will become 0 because wait every time subtracts and signal every time adds. Then you will add the process to the buffer. So again you will add some value, and then signal will reset 0 to 1, and full will become now 1, then 2 plus 1. Okay, so it will become 2. So 2 items are in the buffer. Now what does the consumer do? Consumer does the reverse of it. It will check for the full. So you know, right? So wait every time reduces. So the value of full is now 2. So it will reduce it to 1, and it will check the condition, and it will say that no other process are waiting. So once again it will go to mutex, and mutex value is 1. So every time it will be set to 1 or 0. So it will become 0 here because wait decrements. Then remove an item from the buffer. So it will remove this value, that is v or this. Then it will send to the this thing processing and all that stuffs. Then what it does, then signal mutex. So signal will reset the mutex to 1. So now other process can use this run other kind of process. So that is why mutex is just like a flag. You are holding locking it, and after doing some kind of critical operation you are releasing it. Then what you do, you need to increment the empty. So empty was now n minus 2, right? So it will become n minus 1. So you have incremented one value. So you can see now only one value is remaining because this value is already processed. It depends on what queue you are using. If you are using FIFO, then first in first out, or last in first out, depends. So this way producer keeps on producing one value, and consumer keeps on consuming one value. So what if the it is empty and the consumer is trying to access? Now let us understand. So when it is empty, so my full value will be 0. So when weight is 0, you can clearly see it will be decremented, right? So semaphore, the value will be decremented. So it will become minus 1. So minus 1 less than 0, true. So it will be adding to the list and block the process. So it will not move to the next line of the code. So this is very important in the this critical condition. So consumer will keep on waiting till one value is added to the this thing buffer, means the queue, by the producer. And same thing the producer do. If queue is full and if it tries to add, so empty will be 0, right? So once again wait is minus 1. So 1 minus 1 it will be not allowing, and this way the producer also will be in the safe state. So both of them will be in the safe state. Now let us understand about the read writer problem. So here what we do is, so many of the readers are trying to read some kind of values, but the writer is only supposed to write. So whenever there are n number of readers, we need to allow all n number of readers to share the same content. But when there is a writer is trying to write something, only one writer is allowed to write. So this is important processor. So let us discuss what all variables we are using. So we can see semaphore, we are writing it to rw mutex 1. So what is this rw mutex? Rw mutex is shared by both the process. So this is shared by writer also and reader also. Then semaphore mutex. So this is used to locking only for the reader, and read count is 0. So read count is used to count how many readers are presently reading. So this will be shared by both. So actually all this will be shared by both, but usage is only the mutex will be done by read and rw will be done by both. Let us understand step by step. So first we'll understand the writer process. So what does it do? Whenever a writer try to request, so it will first check whether some reading operation is being done or not. So that is why read write mutex is global for both of them. So what is the value for read write mutex? It is 1, right? So whenever when a wait condition takes any value, it will decrement, so it will become 0, and then it will move to the writing performed, because 0 is allowed in this wait condition. So no other reading is done, so directly it will allow. So writing is performed, so he will try to edit the file or do some kind of operations, and then after completing he will unlock. So now it was 0, right? So after signal it will become 1. So once again it is reset, and the value can be accessed by any of them. So this is a writer proceeds. So whenever one more writer, so writer 1 is accessing, so the value will be 0, right? And he will be performing some kind of condition. So when one more writer comes, so he will reduce value to -1. So -1 is less than 0, then the writer wait will say you need to wait. So it will put the writer 2 in the waiting list until the writer 1 performs. Then after reaching signal, so -1 become 0 because it will increment, and then it will add the second waiter writer, and then produce the same kind of process. So this is the what writer process do. But the reader process, whenever the second reader comes, he should also join with him. So how does he do? So that's why the code is little long, but let us understand step by step. So first thing, the wait mutex. So mutex is used by reader, as I said earlier. So it will try to lock the reader. So only one reader is accessed during this kind of important segment. So you can see one is mutex here and one is mutex here. So he will set the mutex 1. So it was 1, and he will do it 0 because of wait. And after reaching signal, he will increment wait. So he will lock it here and unlock it here. So why does he do? Because read count is incremented, and this is also critical process. So if two readers are simultaneously doing, then there might be chances of getting any kind of failure also. So that's why he will log this value for all the readers, so that only one reader can perform this at a time. So first thing is reader count plus plus. So we will add the, so reader was 0, right? So one reader it will become 1. Then it will check whether the reader added is the first reader or not. Why? Because if he is the first reader, then if any writer tries to come into, then the writer should know that there is some kind of process running. So that is why we used RW mutex. So RW mutex is common for both. So when I set RW mutex, see, if reader is 1, right? So 1 is equal to 1, it is true. So it will use wait. Wait will do decrement. So RW mutex is currently 1. So it will become 0. So when it is 0, then this writer will come to know that somebody is reading the process. So that is why we are using this RW mutex, so that the writer should not write while somebody is reading, and also the reader should not read while somebody is writing. But reader can read when somebody other is reading. So that is why we use this read count. Now this way the read count is incremented. Now what he does, he'll reach here reading performed. So he will do some kind of reading, and suppose the another reader comes, okay? So once again what he does, so if suppose this is R1, okay, now executed. So suppose another reader comes, R2, so he will set it to 0, mutex will set to 0, and then he will add reader count plus. So it will 1 will become 2. So now there are 2 readers reading. Then if read count equals to 1, so it is not, so this is not a first reader, so this is a second reader, it comes to no. So no need of reassigning it to -1 or something, because it should be 0 only, because this is only one operations we are showing. So read the write mutex is 0 or 1 in this case. So signal mutex, so we have logged this, right, till incrementing these all conditions. So we will unlock it using 1. Now the second reader also can perform reading. So how this both of them can stop? So main answer is this thing, wait. So once again wait mutex, so it will try to lock, and then signal mutex, it will try to unlock just as the before. So because this is very important segment from here till here. So once again reader count minus minus, so it was 2 readers, so it will become 1 reader. So if read count equals to 0, so 1 equals to 0, no. So there is still more reader, so don't reset this mutex value to 0. If you reset this mutex value to 1, then the writer will think that there is nobody reading, and he will write the file. So there will be error. So That is why you are checking whether till read means all of them have read the file. Till then you will check, and finally after becoming the read count 0, then you will set the read mutex as 1. So now the second reader also will reach here. He will lock it, then he will do our read count minus, so it will become 0. Now 0 equals to 0 is true, so now all the readers are successfully read, so it will become signal will be incremented of this read write mutex, so it will become 1 because it was 0 set it by here, so it will become 1, and finally the signal mutex it will unlock, and finally it is done. So this way both of them can try to save the file. So now the interesting question is next one, the dining philosopher program. So what it does, so here semaphore chopsticks of 5. So chopstick is a kind of array, so currently I have assigned it to 5 just for example. Okay, 2 3 4. Okay, so how does it work? So consider there is a dining table, and there is a food in the center. Okay, some rice ball or something, and there is a chopstick in all the corners. So now there are 5 chopsticks, so there are 5 people too here, and beside every 5 people there is one chopstick. So what it does, so when anytime if one user, this user want to eat from this, so he need to pick one from right and one from left, and then only he can eat. So if he wants to eat, so he this guy has already taken the chopstick, so he can't eat because he has only one stick, but this guy can eat because he has 2 stick in the right. So this way the chopsticks are used. So now let us understand about the code part. Okay, so how we can perform this. So whenever the one guy is eating some food, he should pick one chopstick from left and one from right. So for that we write the condition, that is weight chopstick of 1 and weight chopstick of I plus 1 modulo 5. Why modulo 5? Because we have array till 4. What suppose if my value is 4 and then 4 plus 1 is 5, it will be out of bound. So it is circular, right? So this is 0, this is 1, this is 2, this is 3, this is 4. So that is why. So first I'll do is give a simple example. Okay, so now let my chopstick of this guy. Okay, 0th person will have some food. Okay, so what he does, he will choose one chopstick from 0 and one from 1. So that is why 1 he will choose from 0, 1 from 1. He will lock it both the chopsticks. So now only this guy can eat, so he will eat for a while, and then after eating he should keep the chopstick back, right? So signal the chopstick, so and signal the chopstick of I plus 1. So he will release this, so this is 0 and this is 1, then he will release both the chopstick down so that other users can have their food. Then he will think for a while because this kind of philosopher, right? He might be thinking till the other one eats. So then he will end the thing. So then next person can have the food. So why we are use modulo? Now let us understand. So what if my, so this is 0 1 2 3 and 4 chopstick. Okay, and person are 0 1 2 3 4. So what if my this guy is 4 having food? So then chopstick of 1 is so I is 4, so 4 he will choose this one left, sorry this is right. Okay, then chopstick of I plus 1, so I plus 1 is 4 plus 1 is 5. So but I need to pick from 0, so that is why we are use modulo, so that it will convert to 0 once again. So 5 modulo 5 is 0, right? So that is why he will choose this chopstick. So both the chopstick after getting, only then he will eat for a while, and then after eating he will release that using signal command, then think for a while. So this is how the code runs. So this was all for today, and if you like my videos, please like it, share it and subscribe it, and thank you all guys for watching.